Now, being compulsive, I like to double check my answer. So you can check it by mass. I'm pretty sure that's right. Let's check the charge balance just to double check. So we have 5 iron plus 2, that's plus 10, plus 8, that's 18 minus 1, plus 17 is the charge on the left. Is it really plus 17 on the right? 5 times plus 3 is 15, and plus 2 is plus 17. Now, the one thing I don't like about the half reaction method is harder to find the agents. So let me take you through the technique. First of all, here's a cute little trick a student once told me. The trick is called oil rig. What does oil stand for? Oxidation is losing. So look at the iron half reaction. You are giving off electrons, you're losing them. Okay, so the iron half reaction is oxidation. Rig, what do you think rig stands for? Reduction is gaining. So notice the bottom one is gaining, it's reacting with electrons, it's gaining electrons, so that's reduction. Now what about the agents? Remember, who causes reduction? The reducing agent. The reducing agent must be in the opposite reaction, so iron must have caused the reduction. It is the reducing agent. Now, who caused the oxidation? It must be in the bottom half reaction. Is it hydrogen? I don't think so. It must be MnO4 is the oxidizing agent. So a little bit trickier, but I think you can handle it. Okay, so we have Cr2O7 negative 2, SO2 gives you Cr plus 3 plus HSO4. Now notice this one shouldn't be too hard to back up, to break up. So we're going to have 2 reactants and 2 products. We're going to match them as best we can. Okay, so you got the Cr2O7 matches with the Cr plus 3, and SO2 matches up with the HSO4. So that kind of makes sense. Okay, so let's balance by mass first. Okay, so we have 2 chromiums on the left, so this has to be a 2 on the right. 7 oxygens. Ooh, we need some oxygen, so 7 waters. 7 times 2, 14 hydrogens, so 14 hydrogen ions. So see if you agree. Is that one balanced by mass? Say yes. Okay, now let's balance the bottom one by mass. So let's see, we got 1 sulfur, 1 sulfur. So these both have to be 1s. Okay, go for the oxygen balance next. 4 oxygens on the right. So we got 2 here, so we need 2 waters to make the oxygen balance. How about the hydrogen balance? We have 2 times 2, 4 on the left. We have 1 here, so we need 3 more hydrogens. That's a job for hydrogen ions. So take a good look at those. See if you agree they're both balanced by mass at this point. Okay, let me raise this so we can go to the charge balance. Okay, so if we look at the top one, we have a total of 2 times 3 plus 6 on the left. On the right-hand side, we have 14 minus 2, that's 12. So we need 12 more electrons, so that's a job for 12 electrons. Now, on the bottom one, let's see, there is no charge on the left. On the right-hand side, we have a plus 3 from the hydrogens, a minus 2, so we need 1 electron. So take a good look at both of those. They're both balanced by charge. The next step is we have to get the electrons to cancel out. Now, I kind of goofed. I didn't write the number on the bottom one, but maybe that's good. You tell me, what number do we need on the bottom one to get the electrons to balance out? Yeah, we have to multiply everything in the bottom one by 6. Matter of fact, why don't you, in your notes, right here, write down times 6. Okay, if we do that, what turns out to be the final answer? Okay, so I'm going to break it up in steps. So we're looking at the top one. Now look at the bottom one where we multiplied everything by 6. Okay, so we're going to have 6 electrons. Okay, so 2 waters times 6 is going to give us 12 waters. 1 SO2 times 6 is going to give us 6 SO2s. HSO4 is multiplied by 6. And the hydrogens are 3 times 6 is 18. Okay, so I think we're done. We can add these together, except we can do some canceling, folks. We cancel the electrons for sure, 6 versus 6. Now what about the waters? 7 waters on the top, versus 12 is going to give us a net of 5. And how about the hydrogens? 14 versus 18 is going to give us a net of 4. So we did some canceling of water and hydrogen. So look at the final answer then. Okay, and if you're compulsive, you can check it by mass. I'm not going to do that, but I would like to check the charge. So we have a -2 ion on the left, so that's a total -2. Do we really have a total -2 on the right? Let's see, 2 times 3 is 6. 6 times 2 is 12. That's a -12. That's a +6. So that's a total -6. Let me do this again. Let's see, we've got 6 times 2 is 12. Okay, what about the agents? Okay, I forgot to write that, didn't I? Okay, classify this reaction right here. Let's see. It looks like it's gaining electrons. So that would be Rig. All right. Rig is regaining electrons. So you're gaining electrons. So that would be reduction. And the last one is you are oil. You're leaving electrons. Electrons leaving, that would be oxidation. So the bottom one's oxidation. So the oxidizing agent should be up here. That would be the Cr2O7. The top one was reduction. So the reducing agent is water. No, just kidding. It's SO2. Yes, I picked this one because I'm not sure how we're going to break this one up. Because we have 2 reactants, but 3 products. How are we going to break this up into 2 half reactions? The answer goes like this. Let's put the Bi2 and S3 in one half reaction, okay? And the NO2 in another half reaction. That kind of makes sense. Now, what about products? Well, the Bi2 becomes bismuth, the S becomes S. So that explains those 2. And in the second half reaction, NO3 becomes NO2. Okay, first step is to balance them by mass. So do 2 bismuths on the left. On the left has to be a 2. 3 sulfurs on the left, this has to be a 3. So that's balanced by mass. How about the bottom one? Okay, so these both have to be 1s to get the nitrogens to balance. So the nitrogens are the balance. How about 3 oxygens versus 2? How are we going to get an extra oxygen on the right? That's a job for water. Now, what about the 2 hydrogens on the right? Yeah, that's a job for 2 hydrogen ions on the left. So look at that. Does that make sense? Does that look like it's balanced by mass to you? Okay, next step will be the charge balance. Okay, so let's see. We have neutral on the left of the first one. We got a +3 on the right, so we're going to need +6. 2 times 3 is +6, so we need 6 electrons on the right. How about the bottom one? Neutral on the right. We've got the 2 hydrogen ions. Oh, I see. In terms of charge, we have a +2 from the hydrogens, a -1 from the SO3. So I have a total +1, so we need 1 electron on the left. What do the numbers 1 electron and 6 electrons suggest to you? Yes, we will hex double the bottom one. We'll multiply it by 6. Everything gets multiplied by 6. Now check out the final answer with me. Okay, so we're going to have 6 times 2, 12 hydrogen ions, 1 bismuth, Bi2S3. Okay, 6 times nitrate is going to give us 6 nitrates. On the right hand side, we have 2 bismuths, 3 sulfurs. Okay, 6 times 1 gives us 6 nitrates, and we have 6 waters. 6 times water is 6 waters. Okay, I think I'm going to check this by mass on both sides. Let's see, 12 hydrogens, check. 2 bismuths, check. 3 sulfurs, check. 3 nitrogens, check. How about the oxygen? 6 times 3 is 18. We've got 12 plus 6 is 18. So I think we're in business. How about the charge balance? Okay, we've got 12 hydrogens, that's +12, minus the 6 nitrates +6. And here we have 3 times 2 is +6. Okay, oil rig. Oil is oxidation is losing. The top one is losing electrons, so the top one is oxidation. Rig. Reduction is gaining. Yeah, the bottom one's gaining electron. That's reduction. How about the agents opposite? Who caused the oxidation on the top? It must be the nitrate. And who caused reduction on the top one? Or on the bottom one? It must be S2O3 is the reducing agent. Okay, I'd like to any questions on that one? Okay, one last example of the half reaction method. So let me lower the screen. Now, what makes this one kind of tough is you're dividing this into two halves. How in the hell are we going to do it? Well, there are two products, so put each product in a different half reaction, and then you have no choice. You got to put the same chemical on the reactant side. Interesting, huh? Okay, so now we're going to balance them by mass. Okay, so the top one is the nitrogen's balance. How about the oxygen balance? We had 3 oxygens on the right. We need one more oxygen on the left, so that's a job for water. How about the hydrogen balance? We have 2 hydrogens on the left, none on the right. Oh, I'm sorry, we have 1 on the right, so we need 1 more, so that's a job for hydrogen ions. While we're at it, we might as well balance this one by charge. Notice there's no charge on the left. We get a +1 from the hydrogen, so therefore we're going to have 1 electron here to make it balanced by charge. So always add electrons to the more positive side. Now let's balance the bottom one by mass and by charge. Let's see, we have NO2 versus NO. We need 1 more oxygen on the right, so we'll throw in water, which is great, except we just put 2 hydrogens on the right, so we need 2 hydrogen ions on the left. So that one, I hope you agree, is balanced by mass. How about the charge balance? Neutral on the right, +2 on the left until we add 2 electrons to make that equal. So we now have 2 completely balanced half reactions, but they won't cancel out because of electrons, so we've got to double the top one. Okay, and now let's see the results of doing that. So we're going to have 2 waters on the left minus the 1 water on the right, so we have a net of 1 water on the left-hand side. And how about NO3s? Well, we have 2 here because we're doubled it, plus 1 more, we have a total of 3. How about HNO3? Well, we doubled that up here, so we're going to get 2 of those. And we have 1 NO, and the electrons cancel out, which they should. And notice the hydrogen ions cancel out also, which is kind of cool. So we double them up here, and that's going to cancel there. So this ought to be the complete balanced reaction. Now, how about agents? The top one, oil. Oxidation is losing, so the top one is oxidation. And the bottom one, rig. Yeah, the bottom one, reduction is gaining, so it gains, that's reduction. Now, how about the agents? Well, the oxidizing agent must be NO2, and the reduction agent is NO2. Kind of wild, the same chemical as both the oxidizing and the reducing agent. Okay, I'm now going to pronounce you experts on the half reaction method. And again, it's my preferred method. I hope it makes sense to you. Okay, I hope this is the next one you have. Let me reduce it in size so you can see it. Okay, now, you're looking at a bunch of half reactions. Now, I want you to change the name slightly on this. I know this is electromotive reaction table. I want you to change it to oxidation table, because if you look at every single one of those half reactions, they are oxidation half reactions. Now, for some reason I don't understand it, this is kind of out of vogue these days. If you look in your textbook, they reversed all these and they call it a reduction half reaction table. Okay, for teaching and learning, this is a superior table.